So this is chapter 7 through 9 review, and we have here, I believe, 10 exercises. Yeah, 10 exercises. They are in chronological order, starting with chapter 7, then 8, and then 9. And I believe there is one exercise that I have decided not to cover for test 2, so I will let you know that one will not be on the test. But as we get to it, I will let you know. So first question. What is the product of the following reaction? And we have here an alkane that reacts with bromine. And so what is the product of reaction of this alkane with bromine? Uh, it doesn't really matter, but alkane is 2,2,4-pentane, trimethylpentane. You don't need to name it, but as products, you have names. To answer this question, you should actually draw these products. Because from the name, it's almost impossible. Maybe you can visualize it. Maybe you can visualize what 1-bromo-2,2,4-trimethylpentane looks like. You can kind of visualize it in your head and say, okay, well, that's reasonable or not reasonable product. But it's too difficult. That's what pen and paper are for. So in each case, you simply draw a structural formula. And so these are A through D structural formulas. That also in part tests, do you know nomenclature? So frequently, one question will test more than one concept. Also, that addresses possibility of, let's say, misconduct, because something like this is not in a textbook. It's almost impossible to look it up on the web. So it really tests you, do you know this material? Can you do it on your own? Because you have to apply your knowledge, and you have to apply knowledge from more than one area, nomenclature and these reactions. And so you have here 4 formulas. Reaction is alkane with bromine. So obviously it's going to be substitution, a free radical halogenation, free radical substitution. Now, then what is the product? First, when you look at these products, there is one interesting thing. Last name, D, is wrong. It's not actually correct UPAC name. I came to an idea to include it because when I was preparing this question, it was easier for me just to draw all these formulas and have program name them and just cut and paste formulas rather than me typing them up. And then it turns out that program, ChemDraw program, older version, named this compound wrong. And so, of course, I provide correct name, but also use the wrong name as one of the choices. I need 4 choices. So when you look at them, you see A and D are correct, sorry, not correct, but they are the same compound. Well, just a little bit of thought about that. If 2 formulas are the same and there is one correct answer to each question, then A and D must be wrong, even if you don't know anything about chemistry, because if you have 2 identical answers, A and D, and only one could be correct answer, then neither A nor D could be correct answer, because in this case you would have 2 correct answers. But this is not correct because bromine is substituting primary carbon. And primary carbon is the least reactive. The order of reactivity is primary, secondary, tertiary. Tertiary is the most reactive. And that's because tertiary free radical intermediate is the most stable intermediate. So A and D are wrong, not because they're identical, that gives you a clue that they can't be correct, but because it's primary carbon that is being substituted. B is not correct because that's secondary carbon that is being substituted. That would probably be minor product. C is correct. That's tertiary carbon that is being substituted. And then C is 2-bromo-2,4,4-trimethylpentane. Question number 2. What is the product of the following reaction? And now we have cyclopentene reacting with bromine. It gives something plus HBr. And this plus HBr is a hint. Because if it's plus HBr, that means it's substitution reaction, just like here. I didn't put here plus HBr, but when bromine reacts with double bond, there are two possible modes of addition. It could be allylic substitution, substitution on carbon next to a double bond, or it could be addition of bromine across a double bond. And how do you know the difference? HBr. Because if bromine adds across a double bond, then there are no byproducts. So there is nothing. It's just the product, dibromo, 1,2-dibromocyclopentane. But if HBr is byproduct, that means only one. So that's one of the two bromines is leaving as HBr. The other bromine is incorporated in the molecule by replacing hydrogen. And so, again, if you draw formulas, A and C would be addition products. And actually, only A is reasonable. A would have been correct answer if it was only cyclopentene plus HBr and no byproducts. You have just a question mark and nothing else. Then A would be correct answer. C is not reasonable because bromine adds anti to give trans product, so it cannot give cis product. Now, actually, I can see that B and D doesn't look right. D 1 bromo 2 cyclo. Oh, okay. Yeah, that's B and D are, yeah, in this case, okay, I did a little bit of trick. So previously, two of them were identical. And I said, well, they can't be correct because two of them are identical. Now two are identical, but B is correct because that's correct name, 3-bromocyclopentene. 1-bromo-2-cyclopentene is wrong name. So that's why B is correct, because B and D are correct formulas, but actually B is correct answer. So yeah, so maybe I wasn't quite correct in saying that here, because A and D are identical, you can eliminate both of them, because one name is correct, the other one is wrong, and in this case you have two identical, one name correct, one wrong, and correct name, one with correct name is correct product. So yeah, it may not be a very good idea to rely then on identical formulas and eliminate both of them. Okay, so let me just see if there are any questions. Okay, there are questions. Have you posted information about the exam format yet? I don't know. I posted some information on the exam, and then whatever I didn't, I will post either later today or sometime tomorrow. In number 2, if the bromine reacted with the double bond, why does it produce a trans product? That's the reaction mechanism. It's a backside attack on the bromonium ion. So reaction mechanism involves backside attack or anti-addition, and the result of anti-addition is trans product. Question number 3. Name 2-methyl cyclohexane is incorrect. So what is the correct name for that compound? And then you have 4 choices. Now, previous questions, first and second, were what we call closed questions, which means when you have a product, you have to look at 4 possible choices, because one of them must be correct, and you don't really want to consider any possible reaction outcome, because one could think about additional reaction outcomes in first 2 cases, and they may not be offered choices, and you don't want to waste your time thinking about could you have, let's say, tribromo compound or something like that as a product. But here, you have an incorrect name, and there is only one correct name. So here what you should do is, first, draw a formula from incorrect name. So name 2-methyl-cyclohexene is incorrect. So you draw 2-methyl-cyclohexene. You draw cyclohexene. Carbons of the double bond are carbons 1 and 2. And you place on 2-methyl group. So that's incorrect name. And then you name it correctly. And then carbon 1 is methyl group. So it's 1-methyl cyclohexane, because nomenclature rules state that carbon of the double bond that is substituted is carbon 1. And so that's 1-methyl cyclohexane. For those of you where internet is cutting, I'm recording this lecture, so Hopefully, recording will be good quality. I cannot control quality of the recording because it's WebEx, but hopefully it's not WebEx itself that is cutting. If it is, that's a problem. But and I'm also recording the sound, so that sound I'm recording separately. So if this recording fails, is a poor quality, then I will post separate sound file. And then you will be able just to play it and go through, follow by going through through this exercise. Okay, so you can expect something like this, not necessarily exactly this type of question, but something like this, incorrect name, so name it correctly. So make sure that you know nomenclature rules. And then question number 4. Name E3-bromo-2-butene is incorrect. What is correct name? Easy nomenclature is something that we'll be covering for the next test. We have left that for another time, or a little bit later. We'll do it in a couple of weeks. So don't worry about that now. So question number 4 will not be on this test. It will be on the test 3. Question number 5. Caryophyllene has the molecular formula of C15H24. Caryophyllene is a natural product, so typical trivial name. So C15H24. It has 2 double bonds and no triple bonds. How many rings does it have? So you need to calculate the number of degrees of unsaturation. So 2n plus 2, a formula for number of degrees of unsaturation is 2n plus 2 minus m divided by 2. N is number of carbon atoms. We have 15 carbon atoms. So 2 times 15 plus 2 minus m. M is number of hydrogen and halogen atoms. There are no halogens here, so we are only considering number of hydrogen atoms, 24. So it's 2 times 15 plus 2 minus 24. So 2 times 15 plus 2 is 32, minus 24 is 8, divided by 2, 4. So there are 4 degrees of unsaturation. Sometimes some students stop here, and in this case, such students will be confused because there is no 4 as the answer. Sometimes I will intentionally include 4, like possible answers, 1, 2, 3, 4. And if you stop here, then it's wrong answer, because yes, there are 4 degrees of unsaturation, but that's not the question. Question is how many rings are there. And so each degree of unsaturation is either a pi bond or a ring. Here we have 2 double bonds. That means 2 pi bonds. So out of 4 unsaturations, 2 are pi bonds. That means remaining 2 are rings. And so correct answer is C, 2 rings. Question number 6. Which alkene is the most stable? And so you have cis-2,3-dibromo-2-pentene trans and so on. Again, draw them. Don't try to pick them from the formula. The only way you would be picking them out of the formula is if you're running out of time. Make sure you answer every question. There is no penalty for guessing. So if you have 30 seconds left, just go through, make sure you answered every question and just guess. So here are the formulas. And so what you're looking at, you count number of substituents. Pretty much anything other than hydrogen is substituent. Now, there are exceptions, but at this level, this is introductory organic chemistry course. This is good rule when estimating stability of alkenes, is to consider anything other than hydrogen as a substituent that stabilizes double bond through hyperconjugation. So A has 4 substituents. It has no hydrogens on double bond. B also has 4 substituents. C actually has 3 substituents. This is alkyl group, methyl, another alkyl, and bromine. 3 substituents and 1 hydrogen. And D also has 3 substituents. The more substituents there are, the more stable double bond. So A and B are more stable than C and D. So it's either A or B that is the most stable. A is cis, with 2 large bromines on the same side. B is trans, with 2 large bromines on the opposite sides of double bond. Trans, in general, has less steric hindrance because large substituents are on the opposite sides of double bond, as far apart from each other as possible. So that's why B is correct answer. Again, let me see if there are any questions. Yeah, there are some. Okay, just, oh, no, nothing else. Okay, address this. Question number 7. A compound with molecular formula C8H11Cl reacts with 2 equivalents of hydrogen in the presence of palladium. How many rings does it have? That's variation on the previous question that we covered, where we were told that there were 2 double bonds and no triple bonds. Here, instead of telling you that, we tell you that reaction is with 2 equivalents of hydrogen. Alternatively, we could have told you that reaction is with 2 equivalents of bromine, because either hydrogen or bromine react with pi bonds. So each equivalent of hydrogen, either hydrogen or bromine, reacts with 1 pi bond. Reaction with 2 equivalents of hydrogen tells you there are 2 pi bonds. And so, as before, you have to calculate degree of unsaturation. So degree of unsaturation in this case is 2n plus 2, I'm same formula, minus m divided by 2. So 8 carbons, 2 times 8 plus 2, minus number of hydrogens and halogens. And this is where a lot of students make mistake. They take number of hydrogens, 11, and forget to include number of halogens, chlorine. Fluorine, chlorine, bromine, iodine, those are halogens. We have to add them. And so if you have 11 here, it will be 2 times 8 plus 2 minus 11 divided by 2, 3.5. And now, what do I do now? I have half an unsaturation, 3.5. So if you have fractional unsaturation, you made a mistake. So go back, find out where is the mistake. So in this case, mistake would have been not including chlorine. So 11 and 1, that's 12. And so 2 times 8 plus 2, that's 18, minus 12, that's 6 divided by 2, 3. So there are 3 degrees of unsaturation. 2 of them are pi bonds, and that means 1 unsaturation is a ring, so B is correct answer. 8. What is the major product of the following reaction? This is a little bit challenging, and you can expect maybe even 2 or 3 questions on the exam that involve rearrangements. So you have to recognize that this is ionic reaction that proceeds through carbocation as the reaction intermediate, and that rearrangement occurs. So what is the major product? So in this case, you have vinyl cyclobutane and reaction with HBr. So the best way is to figure out product on your own. These 4 could help you as a guide, because if you end up with product that is not one of these 4, then look at your writing your mechanism and figure out where you made a mistake, and this could help you arrive at one of these 4. So first step is protonation of the double bond. That gives intermediate carbocation. Carbocation is next to a small ring, 3 or 4 membered ring. And remember, when small rings are involved, then they undergo ring enlargement. So one of the bonds from the ring shifts to carbocation to give larger ring, 1 carbon larger. So 3-membered ring will give 4-membered ring as a result of rearrangement, 4-membered ring, 5-membered ring. And because this double bond has moved from the ring, now electron deficient carbocation will be carbon of the ring next to this substituent, next to where the double bond, not double bond, next to where this bond has moved. And then reaction of this newly formed rearranged carbocation with nucleophile gives the final product. So correct answer is C. So make sure that you know this whole process of the rearrangement and how to identify the product. Having said that, these are more challenging questions. Now, I hate to tell that to students, because sometimes when I identify certain type of questions as more challenging, some students simply don't even bother and won't do them. And that's not a very good idea. Now, when you have limited time, yeah, you should spend more time on easier questions and make sure that you get points on those, that you don't make mistake on easy questions. But still, these are not impossible to do. So hopefully you won't give up if you see a question like this. But at the same time, if you're just aiming for a C or something like that, you may want to spend more time on other questions, and this one, if you have the time, or just make a guess. But again, it's not that it's not worth bothering. Okay. Yeah, let me see. Do you need two hydrogens to break one pi bond? Well, yeah, two atoms add across a double bond, or two groups add across a double bond, nucleophile and electrophile. So it would be two hydrogens. Question number 9. What reagents would you use to prepare 2-bromo-1-chloropentane from 1 pentene? So this is 1 pentene and product. So actually when it's written like this with names, again, rewrite that as chemical equation. That's why we use chemical equations, so you can visualize what is the outcome. And so that means addition of bromine and chlorine across a double bond. So how are you going to accomplish that? Here we have reagent, I forgot the name. I think it's bromine chloride, or bromonium chloride. We don't cover this reagent, and it's not a reasonable choice. Could give some of these products, but not likely. Well, might, I don't know. Probably we would have mixture products. Chlorine, here are the two that you may recognize from the class. Chlorine in the presence of excess of potassium bromide, or bromine in the presence of excess of sodium chloride. So chlorine will produce chloronium, cyclic chloronium ion, bromine, cyclic bromonium ion. And so the question is, which one do we need? And we need cyclic chloronium ion because bromine ends up on more substitute carbon. When cyclic chloronium or bromonium ion is formed, then nucleophile in backside attack forms a bond to more substitute carbon. So if bromine ended up on more substitute carbon, that means bromine has to be a nucleophile. And these salts are sources of the nucleophile, Br minus or Cl minus. So if bromine is on more substitute carbon, that means Kbr is source of Br minus. If chlorine were on more substitute carbon, then we would have used sodium chloride for Cl minus, and then bromine would have been the reagent, bromine and NaC. Let's see, we have only 10, yeah. And finally, question number 10. What is the product of the following reaction? Addition of bromine across a double bond, and you can see from the answers that you are supposed to figure out stereochemistry. What is the stereochemical outcome of the product? We have 4 possible products, and you need to basically analyze them to consider what is the outcome and what is different between these 4 products. 3 of them involve 5-membered ring. Last one, 6. So that would be a ring enlargement from 5 to 6-membered ring. From what you have learned so far, you would not expect that. Although such reactions could occur, and this is actually something, for example, occasionally students, again as part of misconduct, would get somebody, let's say a graduate student, to do a test for them. And the graduate student doesn't know what you have covered in this class. Graduate student is not taking this class, or maybe postdoc. And so there are conditions and possibilities where D could be correct answer. And so I would end up sometimes with students vigorously arguing with me why that's not correct answer. I know that, I'm sure. Well, that's right away I know that person got somebody else to take a test for him or her. First, because we did not cover this in the class, it's not the correct answer. But under certain circumstances, there could be ring enlargement if this was carbocationic mechanism and so on. Again, we don't cover anything like that in this course. You're covering a little bit simplified organic reactions. It's an introductory organic chemistry course. And so as soon as somebody starts introducing more advanced concepts, particularly applying them not appropriately, that's a good reason for me to suspect that somebody else is taking the exam. So A, B, or C are correct. One of those is correct. because what you have learned so far is to consider ring enlargement only if starting ring is 3 or 4 membered, not 5 membered. And so what do we have in A, compound A? Two bromines are cis to each other. That's the result of syn addition. But addition of bromine, as you have learned, is anti, to give trans product. B is trans. One bromine is down, one is up. One below the ring, another one above the ring. So that is that looks like a correct answer. And C is also cis. In case of A, both bromines are above the plane of the ring. That's cis. C is also cis, both below the plane of the ring. Both on the same side of the ring. Both above or both below is cis. Addition of bromine or chlorine across double bond gives trans product. So B is correct answer. And you can consider reaction mechanism, and that will help you. Okay, so that completes A and C are not the same, and you may, at this point, you may not quite realize that A and C are not the same, but when we cover chapter 11, we will realize that A and C are not the same. At this time, well, you can say, well, yeah, they're the same. They are both cis. So we cannot teach you everything at the same time. We have to teach course one topic at a time. It would be nice if we could kind of cover everything that just like at once, but we are not there yet the way we can teach chemistry. So yeah, bromine is anti because it is backside attack. That's correct. Okay, I would like to stop recording now.